Okay, so question number 60 on page 477 states, Richard deposits $1,000 into a guaranteed investment certificate, a GIC, that earns 4.3% per year with simple interest. And part A tells us to develop a linear model to relate the amount in the GIC to time. So we know that simple interest can be converted into a linear formula. So y equals mx plus b. And we know that y is equivalent to a. Then m part is going to be 45. And then t is going to be your x plus your initial value, which is 1,000. That is going to be our formula. And then I'm just going to do a rough draft of the graph with the initial value being 1,000 and your time being over here, which is also your x value. And then we're going to have like 45 intervals over here. And then I'll show you in a more professional graph how our interest is going to increase due to this linear formula. So I just want to add on that our 1,000 represents the initial value, or the fixed part, and the 45t is representing your variable part, which is mx. So part B of question number 60 says, how long will it take to the nearest month for the investment to double? So we know that our initial investment was $1,000, and then if you're doubling that, it equals $2,000, and we're trying to find t. So the linear formula that we came up with previously was y equals 100 plus 45t, with initial value and then the mx. Then this is a b. So we're going to use the same formula, but we're going to put as our amount, which is a. So we're going to do 2,000 equals 1,000 plus 45t. And then when you subtract this, so 2,000 minus 100 equals 45t, 1,000 equals 45t, then you're going to divide both sides by 45 to substitute for t, which is what we want over here. So your answer is going to be 200 over 9 as t, but we're looking for years, and if you were to put this in your calculator, it would actually be 22.222, and then we want in years. So we have 22 wholes, which is 22 years, and this over here is going to be a fraction part, which is equivalent to 3 months, because 3 over 12 would give you the 222 part in our answer. So your answer is going to be 22 years and 3 months. So part C of question number 60 says, what annual rate of interest must be earned so that the investment doubles in 6 years? So we are going to use the simple interest equation, which is A, amount, equals principal, rate, time, plus P. This is all multiplied together. So we know that T equals 6 years. Our principal value is $1,000. And the amount that we want is investment doubling, so 1,000 times 2, which is equal to $2,000. Now we are going to use this formula to figure out how long it will take for it to double, or what the annual rate of interest should be so that it doubles in 6 years. So we're going to do 2,000 equals principal times rate. Sorry, I'm just going to move this over because I don't have any room. So 2,000 equals 1,000 times your rate times 6, which is your time, plus 1,000. So you're going to subtract 1,000 from 2,000, which is equal to 1,000. Then when you multiply 6 by 1,000, you're going to have 6,000 R. And then you're going to divide 1,000 by 6,000 for R, which is equivalent to 1 over 6 equals R. But you want a percentage rate for your interest. So this is also equal to 0.0166, and the sixes continue, but you want interest rate, so you're going to multiply this by 100, which gives you 16.7777, and that is also equal to a 16.78 interest rate. So now we're going to be looking at solutions for question number 60. The textbook says for part A, amount equals 1,000, your fixed rate, plus 45t. We just put it in a different arrangement, 45t plus 100 for y equals mx plus b, which is right. And then for part B, it says in the textbooks 22 years and 3 months. And if you look in our answers, or our solution, sorry, we got 22 years and 3 months, which is also correct. Then for part C, for question number 60, we got 16.7 interest rate. And if you look over here, we got 16.78 because we just rounded up, which is correct.